apologize. It closed my PowerPoint out, so let's try this again. So even is symmetric with respect to the y-axis, so it reflects across the y-axis, whereas odd is symmetric with respect to the origin. So that would be more of a diagonal type symmetry. So something like this, where it reflects across here. All right, so let's say you have something like f of x equals x cubed minus 6x. So to test to see if it's even or odd, you're going to plug in a negative for the x, a negative x instead of x. And then you're going to see if it comes out to the same exact function, it'll be even. And if it comes out to the exact opposite of the original function, it'll be odd. And if neither of those occur, so maybe there's a combination of the two, it would be neither. So I'll just plug in negative x everywhere there's an x. So I get negative x cubed minus 6 times negative x. Well, if you do negative x times itself 3 times, you get a negative x cubed. And here a negative times a negative is positive 6x. So if you notice, these signs, negative and then positive, are exactly the opposite of the original. This was positive and then negative. So since it's the exact opposite, it's going to be odd. Okay, let's say you have another one like f of x equals x to the 4th minus 2x squared. So you'll plug in a negative x. It gives you a negative x to the 4th minus 2 times negative x squared. Okay, negative x times itself 4 times is actually a positive x to the 4th. And then negative x times itself twice is a positive x squared. So if you notice, you have the same exact function as you started out with. So this is going to be even. Okay, and let's say you have something like f of x equals x squared plus 2x plus 1. So again, you'll plug in a negative x. So you plug everywhere there's an x, you'll put a negative x. Negative x times itself is x squared, positive. 2 times a negative x is negative 2x, and then I have the plus 1 on the end. Okay, and if you notice, it's not exactly the same as it was originally because of this sign right here. So it's not even, but it's also not odd because in order to be odd, all of these signs would have to be opposite. So this would have to be negative, 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 and that is not the case. So this is actually neither. Okay. Another thing you'll be asked to do is to look at piecewise functions. So a piecewise function is basically where instead of having something like just f of x equals 3x plus 2, we're going to say, well, it's 3x plus 2 when x is within a certain range, so a certain domain, I guess we should say. So let's say it's only this function if x is less than 0, but then it's this function if x is greater than or equal to 0. So you're kind of going to have two lines, maybe something like this. So it's one of the equations for a certain point, and then another equation from there on out. So they're going to ask you to evaluate. Oops, it'd help if I could spell. So let's say I want to evaluate f of 3. Okay, so remember that this is the x value. So I'm going to use one of these functions to evaluate it. So I'm going to be plugging the 3 into one of these functions, but I have to decide which one. So that's where the domain comes into play. So I need to figure out if this x value is less than 0 or if it's greater than or equal to 0. It is greater than or equal to 0 because 3 is larger than 0. So I'm going to use this equation. and I'm going to plug in 3 where the x is. So that gives me 12 minus 7, which is 5. So the answer is 5. Now if I have f of 0, okay, well you look and see, is it less than 0 or is it greater than or equal to 0? Well, it's equal to 0. So again, I'm going to use this function and I'm going to plug in 0 for x. So I get 0 minus 7, which is negative 7. Now let's say I have f of negative 2. Okay, so x is negative 2, which is less than 0. So I'm actually going to use this function now to evaluate. And instead of x, I'll plug in the negative 2. So I get negative 6 plus 2, which is negative 4. Okay, now if you're asked to graph these, there are a couple ways you can go about doing it, but one of the most popular ways is to plug in some values. So let's say I want to graph this function, f of x, and we put these little brackets to show that there are 2 sections, or 2 or more, I guess. So it's negative 3x. We're going to graph f of x equals negative 3x if x is less than or equal to 0. And then we're going to graph the function f of x equals negative 4 if x is greater than 0. So on your graph, you are going to pick some values. So when x is less than or equal to 0, so I would pick some values that are less than or equal to 0. So since it's equal to 0, I would put f of 0 as one of them. So if I plug in 0 to that function, I get negative 3 times 0, which is 0. So at 0, it's 0. And then some other values when x is less than or equal to 0. Well, if x is negative 1, that's less than 0. So I could plug that in. Negative 3 times negative 1 is positive 3. So at negative 1, I'm at positive 3. Let's try another one. F of negative 2, that's also less than 0. So negative 3 times negative 2 is positive 6. Oops, I'm not in myself in the room here. Okay, so now I can connect those. And I'm going to stop at 0 because it's when it's less than or equal to 0, and then anything above 0 is going to be a different graph. So I'm going to stop there. Now, it's going to be at negative 4 when x is greater than 0. So I'm basically going to pick up where I left off. So beyond 0, all the y values will be at negative 4. So when x is 1, it'll be at negative 4. When x is 2, it'll be at negative 4. When x is 3, it'll be at negative 4. Now, if I ended here at 0, I have to start here at 0. But I also want to show that it's not equal to 0 there. So I'm actually going to put an open circle there to show that it does not include 0, but it includes everything above 0. Okay, so that would be the graph. Another way that people like to do it is they'll sometimes graph this equation, f of x equals negative 3x. Okay, so that's if you think of mx plus b. That's a slope of negative 3. And there's really a plus 0 here, so the y-intercept is 0. So if you start from 0 and then go down 3 over 1, and then go the other way over 1, if you were to graph this line, that's the graph of f of x equals negative 3x. But we want to show that it's only that line when x is less than or equal to 0. So you find where x is 0, that's right here. And when it's less than 0, that's this way, right? So I'm only going to keep this portion of the graph. So I'm going to erase all of that. Okay. And then the other thing you could do, well, right, f of x equals -4. That's just a constant, so a line at -4. But I only want that when x is greater than 0. So I find where x is 0, and I only want above 0, which is to the right of it. So I'm going to erase that part. Whoops. Okay, this machine is not working very well. Okay, and then since I don't want to include 0, I'm going to put an open circle there. So either way you'd like to do that is okay. But you'll notice they never overlap because then it wouldn't be a function. So wherever it ends, that's where it has to start for the next part of the graph. Okay, the last thing you're going to be asked to do in the homework is to evaluate and simplify the difference quotient, which is this function, and f of x plus h minus f of x all over h. And this is actually something you'll use once you get to calculus. So we're learning how to simplify it now to help you later. So let's say the function is f of x equals 5x. Okay, so first you need to find f of x plus h. So that means to plug in x plus h instead of x. So it's going to be 5, and instead of x, we'll put x plus h. And then if you simplify that, distribute the 5, that's 5x plus 5h. Okay, so I'm going to take f of x plus h. So that gives me 5x plus 5h. That's f of x plus h. Minus f of x. F of x was 5x, so minus 5x. And that's all over h. And then we just simplify this. So the 5x minus 5x, that cancels out, leaving us with 5h over h. And then we can simplify it even more because the h's will cancel out. And so my answer is going to be 5. Okay, let's say you have something a little bit more complicated. So let's say you have something like f of x equals 2x squared minus x minus 1. Okay, so we need to find f of x plus h, which means everywhere there's an x in this function, I need to plug in an x plus h instead. Okay, and now I need to simplify this. So x plus h squared means x plus h times x plus h. Okay, here I'm going to distribute the negative to both, so negative x, negative h, and then I still have the minus 1 on the end. Okay, now this thing you need to basically FOIL it, or double distribution, however you want to think of that. So x needs to get multiplied by everything in the second parentheses, and h needs to get multiplied by everything in the second parentheses. And I still have this 2 out front. So x times x is x squared. X times h is xh. H times x is hx or xh. I'll write xh so I'm consistent with the last one. And then h times h is h squared. And then I still have this on the end. Okay, I can actually combine like terms here. So I have x squared, xh plus xh, that's 2xh. Okay, and then I can distribute this 2 to the parentheses, so I get 2x squared plus 4xh plus 2h squared minus x minus h minus 1. Okay, so that's f of x plus h. Whew. So that's what I'll plug in here. So I have 2x squared plus 4xh plus 2h squared minus x minus h minus 1. And I need to subtract f of x. So minus this function, 2x squared minus x minus 1. And that's all going to be over h. All right, now this, I'm subtracting this whole function, so I need to distribute the negative. So I have 2x squared plus 4xh plus 2h squared, kind of long, huh? Minus x minus h minus 1. And then I get a negative 2x squared, a positive x, and a positive 1. So basically just think of this negative as changing the sign of everything that f of x has, each term. Okay, and that's over h. Now here's the nice thing, some things cancel. Look, I have a 2x squared and a minus 2x squared, so those will cancel. I have a negative x and a positive x, so those will cancel. I have a negative 1 and a positive 1, so those will cancel. So I'm left with 4xh plus 2h squared minus h all over h. And if I break those down into their own functions, I have 4xh over h plus 2h squared over h minus h over h. Well, that one, the h's will cancel, leaving you, I'm going to write this up here, with just 4x. And then here, h squared over h, one of those h's will cancel, so I'm just left with 2h. And then here, h over h is just, anything divided by itself is just 1. So I have minus 1. And that would be your answer. So kind of a lengthy process when you get more advanced like this, but just keep trucking through and simplifying. You're going to do this x plus h squared sometimes, so if you just want to know that it is x squared plus 2x h plus h squared, that'll save you a few steps. All right, and that concludes section 2.2. If you have any questions, let me know.